Hello students, this is mathematics in the channel Learning Mathematics Without Tears with Mrs. Kerry. Today I'm teaching you on the subtopic of enlargement under the topic of similarity and enlargement, and the knowledge you're supposed to be having when we are doing this topic is use of Cartesian plane on your graph book. Now, enlargement is a transformation process that we do in mathematics. We have other transformation processes like rotation and reflection, which you have already covered there before. Therefore, transformation is a process that can change the shape, the size, the direction, or the position of an object in the image. Under enlargement, the shape of the object and the image remain the same. But what changes is the size. The size may increase or decrease. We are going to see three important things that you are supposed to have when you are undertaking enlargement. First, you have the object, which may be given or it can be what you are required to look for. But once you have been given object, you are required to have the center of enlargement. And you are also supposed to have enlargement scale factor. Enlargement scale factor, you have already come across scale factor, especially linear scale factor, when you are doing similarity. So with the center of enlargement and enlargement scale factor, if you've been given the object, it is now very possible for you to get the image. Now, the very first exercise that we are going to do is to find enlargement. It is to find the image when given object. You are given the object, you are given the center of enlargement, and you are given the enlargement scale factor. So you're supposed to look for the image. We have an example here, and we have been given a triangle A, B, and C, and you're told it is enlarged by scale factor 2 through the center of enlargement 0, 0. We call 0, 0 the origin. So you're supposed to find the image A prime, B prime, C prime. So the very first process of looking for the image is that step 1, you're supposed to draw the object on the Cartesian plane. You're supposed to draw the object on the Cartesian plane. So you have A, plot A, which is 1, 1, B, which is 2, 1, and C, which is 2, 3, and join them to form your triangle ABC. After you have now drawn the object A, B, C, step 2, you're supposed to join OA, join O to A. So you're supposed to join O to A. Then measure OA. Measure the length OA. You're supposed to measure this using your ruler. So suppose you get your OA is 2 centimeter. Suppose you get that OA is 2 centimeter. What else are you going to do? Step 3, is that extend the line OA from A. You extend it from point A, you extend it onward. So after you have extended OA, now we want to get A prime on the line that has been extended. So we know that scale factor is usually the image over the object. So our image will be OA prime, that is the length of the image, then OA is the length of our object. So this one is the one that we are saying the scale factor is 2. So if you had gotten OA as 2 centimeter, then you're going to say OA prime over 2 centimeter is 2. Multiply both sides by 2, and you get that OA prime is 4 centimeter. So in other words, we are saying you have joined O to A. Then you extend that line. OA is 2 centimeter. Therefore, with scale factor 2, OA prime should be 4 centimeter. So you get your A prime. Now, for you to be able to get the image of B and C, you are going to repeat the same process as you have done to get the A prime. So you'll join O to B, and then measure OB, then extend the line OB, and then divide, that is, to get the scale factor, it is OB prime over OB. So in case you had gotten this is OB, therefore let's say you have gotten your OB as 3 centimeter. Extend the line OB, and then OB prime over OB will be 2. So here OB is 3. So when you multiply 3 on both sides, you'll get your OB prime to be 6 centimeter. So this one from O to B prime is 6 centimeter. Repeat the same process for C, that is join O to C, extend the line, measure OC. Suppose OC is 4 centimeter, then OC prime will be 8 centimeter. You will realize that when our A was 1, 1, A prime is 2, 2. When B was 2, 1, B prime was 4, 2. What would be happening in this case? Now we come up with a formula from this. If A was 1, 1 and at the enlargement scale factor 2, we are getting A prime as 2, 2. You can see that the coordinates of A have been multiplied by 2 in order to get the new coordinates, or the coordinates of the image. So in general, we can say that when we have A, which is xy, to get the image of A at the enlargement scale factor k, now we call our scale factor k, then A prime will be kx, ky. This is so important. It is important that you realize that that is our general formula for enlargement given the scale factor. But I have to say this only applies, it only applies when the center of enlargement is 0, 0. It only applies when the center of enlargement is 0, 0. For all the cases. Now, we move on now. This example I had given you, the scale factor was 2. I want to give you a scale factor that is less than 1. So let us see what is going to happen. We have been given PQRS as an object such that its vertices P is 6, -2, 8, Q is 8, -2, R 8, -4, and S is 6, -4. You've been told to find the image P prime, Q prime, R prime, S prime under enlargement, scale factor half, with the origin as a center. And I've said origin is the same as 0, 0. So the very first thing, as I earlier said, the step 1 is that you plot the points for P, Q, R, and S, and then join to form the object. After that, the process still continues. What I had earlier said, that join OP, join O to P, extend the line OP. In this case, we are going to see whether we really actually require the extension. Our scale factor is a half. So scale factor is equals to OP prime over OP. So if we had measured OP, can we say here, instead of saying extend, let us say measure. If OP was 4 centimeters, let us see how we are going to get OP prime. So OP, this is the same as a half. So OP prime over OP, which is now 4 centimeters, is equals to a half. Multiply both sides by 4. So you are going to realize that our OP prime will be less. It will become 2. So measure the length from O, 2 centimeters, and when you measure the 2 centimeters, that is where you are going to get your image P prime. Repeat the same process for Q. Join Q to O, measure the length O to Q, multiply that length by a half, which is our scale factor. So where you get the half, that is where your Q prime will be. Same case with S and R. So you repeat that same process. And you also realize that the same formula that we had here, it is applying in our case here. So for example, our P was 6, -2. Our scale factor is a half. If we multiply 6 by a half, then we shall be able to get 3. If we multiply -2 by a half, we are able to get -1. So our formula here applies. Now I want to give you, there's something that you're going to note, that the image is smaller than the object. But both the image and the object are on the same side of the center of enlargement. Now the difference between example 1 and example 2 is that in example 1, the image was bigger than the object. Why? Because the magnitude 2 was greater than 1. Here, the image is smaller than the object. Why? Because the scale factor has a magnitude that is less than 1. The third example we are going to do is one where we have a negative scale factor. We have been given a quadrilateral that has vertices K 4, 6, L 2, 2, M 4, 4, and N 6, 2. It is enlarged by a scale factor -1/2. The center is 0, 0. Now you are told to find its image. If you plot the points K, L, M, and N on the Cartesian plane, this is the object that we are getting. K, L, N. It's a quadrilateral. So now to get the image, the process is the same. We are going to you get the image of each vertex. So for example, you are getting the image for K. So you are going to join O to K. Now, in this case, you are not going to extend the line on the side of K. The negative scale factor means that we are going in the opposite direction. The vector. This is a vector. Negative means go on the opposite direction or on the other side of O. So you are going to extend. You join K to O and then extend the line on this side. Still a straight line along the line KO. So the ruler is still at KO, but you extend the line on this side. Then measure OK. So for example, we say OK is 4 centimeters. So to get our OK prime, or the position of K prime, we shall say scale factor is equal to OK prime over OK, which is negative a half. So OK prime over 4 is equal to negative a half. Multiply both sides by 4, and then you get that our OK prime will be negative 2. This negative means you are going on the opposite direction. Therefore, measure from O on this side, you measure 2 centimeters to get your K prime. Where you get the 2 centimeters, that is where your K prime is. You are going to repeat the same process for L. Join L to O. Then extend the line on this other opposite side. Whatever measurement you get of OL, multiply by a half, and then you measure whatever product you get on this side, and where you get that measurement, that is where your L prime will be. So same case with N. Again, join N to O, measure ON, multiply by negative a half, and then whatever magnitude you get, you measure it on this other side of the graph. That is the opposite side of the center of enlargement. Same case with M. You realize that it still applies the same formula, that to get the image of a coordinate K, you need to multiply 4 by negative 2. So when you multiply 4 by negative 2, we get negative 2. When you multiply 6 by negative 2, we get negative 3. So it also obeys our rule that when we have a point A with xy and we are enlarging with scale factor K, then the image is Kx and Ky. Now we are through with our examples. I want us now to do the deductions. From the 3 examples that we have, what can we deduce? Number 1, that the image at the enlargement retains the shape of the object. Remember, we said enlargement changes the size. So it can increase or decrease the size, but the shape remains the same. Number 2, the image at the enlargement with positive scale factor is on the same side of the center of enlargement with the object. So you can check what you've gotten in example 1 and example 2. Both the object and the image were on the same side of the center of enlargement. Now, under this, we have to take care of two things. That when the scale factor is larger in magnitude, and why I've used the word magnitude is that I am dealing with the size and not necessarily whether it is negative or positive. So when the magnitude is greater than 1, then the image is usually larger than the object and further away from the center of enlargement. So you can look at example 1 to see this condition. Then number 2 is that when the scale factor is less in magnitude, that is less than 1, e.g. a half, the image is smaller and nearer to the center of enlargement than the object. These two examples can also apply when the scale factor is negative. I've used the examples where we had positives, but it can also apply when the scale factor is negative. Lastly, the image under enlargement with a negative scale factor is on the opposite side of the center of enlargement as the object. That is, if the object is on this side and this is the center of enlargement, the image will be on the other side of the center of enlargement. So it is on the opposite side of enlargement and it is inverted. You can see example number 3. Whenever the scale factor is negative, the image is inverted and it's on the other side of the center of enlargement. So that is our topic today, and I wish to request you to do some few examples from your textbooks so that you may be able to learn this enlargement in a better way. I'll give you also a challenge. Go and try to find, this is a challenge, find object given scale factor, center of enlargement, and the image. Suppose you are given the image and now you need to find the object. What process are you going to do? So with that, I wish you all the best, and we are through with our lesson today. Thank you.